Hello everyone. Based on popular demand, we'll be discussing naming of organic compound. Okay, so for those of you that have been having issues doing this, I am responding to your plea. All right, for naming of organic compounds, but before I move on, please, I beg you pay serious attention to things that will be discussed here. Okay, I really need you to just follow me here. All right, now in naming organic compounds, it follows a sequence which is prefix or prefixes, we have roots, and we have suffix or suffixes. Okay, and in doing this, I want you to know that this is actually can be compared to a word in English language, okay, wherein the root still is compared to the base word that stays in the middle. The prefix, still the prefix we know in English language that stays at the left end of a word, and the suffix stays at the right end of a word. It can be the last syllable, as the case may be. People in English language will tell you better. Okay, back to chemistry. Now, in this naming sequence for organic compounds, the root is usually named first. Okay? After naming the root, the next thing that follows is the suffix. Then, after the suffix, we'll now go over to the prefix, which is named last. The next thing is how do we go about each of these items in the IUPAC naming of an organic compound? Okay, let's start with the first. First things first. The number one root is obtained from the number of carbon atoms in the longest continuous chain. Okay, that is where the root is obtained. Then the suffix number two is obtained from the functional group. Okay, obtained from the functional group. While number three, the prefix, is obtained from the substituents. From the substituents or substituents. Some people call it substituent groups. It's still the same thing. All right. Now, before now, if you've been introduced to organic chemistry, you should know what is meant by functional group as well as substituent. For functional group, need I remind you that it is simply a bond, which could be single, double, triple, or an atom or group of atoms attached to an organic compound, which determines its chemical properties. Okay. Then for the number of carbon atoms in the longest continuous chain, when they say longest continuous chain, that is to say any route that you take in the skeleton, in the arrangement of a compound, an organic compound that has the highest number of carbon atoms, that is what we refer to as the longest continuous chain. Then for the substituents, when we say substituents, just like in math, when you say substitute x equals 1, these are atoms or group of atoms that will take the natural place of hydrogen in organic compounds, including hydrocarbons. Okay, so in this sequence now, we'll discuss each and every one of them one at a time. We'll start from the name as root. Okay, so I'll be rubbing off the board. If you want to get this, you pause the video and get the information noted down. All right, let's discuss name as root. Name as root. Okay, when we talk about name as root, okay, it determined is determined by the number of carbon atoms. Okay, all right, not just the number, but the highest number of the carbon atoms in a chosen root. Okay, let me say in a chosen skeleton. Let me put it this way so that it makes more sense to us. Okay, and in this naming, I will show us the name as root from number carbon atom number 1 to 10 at least. That will take care of both the WAEC, the NECO, the IGCSE, even the JAM. Okay, so let's see number of carbon atoms. Let's see name as root. Okay, 1, the name as root is meth. 2, the name as root is eth. 3, the name as root is prop. 4, the name as root is but. 5, the name as root is pent. 6, the name as root is hex. 7, the name as root is het. Okay, I permit me to continue from here. 8, the name as root is ox. 9, the name as root is none. And 10, the name as root is deck. I'll stop here. Okay, so I'll just leave the space so that you take screenshot or you just go through it and know what is happening here. If you also notice, the names as root, they have hyphens written in front because they are not complete words. They are part of a word or a name in this case. Okay, so this is how we name our root based on the highest number of carbon atoms in a chosen chain or skeleton, carbon skeleton. All right, so that being said, let's go to name as suffix. Name as suffix. Okay, for name as suffix, as we earlier on mentioned, it is obtained from what? The functional group of an organic compound. Okay, so we'll see some functional groups and their names as suffix. Functional group. Okay, name as suffix. The first one, let's say single covalent bond. The name as suffix is ane, A-N-E. Double covalent bond. The name as suffix is ene, E-N-E. Triple covalent bond. The name as suffix is yne, Y-N-E. Then group of atoms like OH. The name as suffix is ol. Another group of atoms as COOH is oic acid. This can also be written as C double bond single then H. So either this or that goes for oic acid. Then if you have something like this, a group of atoms like COO, this can also be OH. This is for esters. Okay, OH. All right, so depending on the functional group in an organic compound, these are some examples of their names as suffix. And if you notice here, the name as suffix has a hyphen in front on the left end, meaning that it joins onto the other part of the name or the word, just as we have it in English language. Okay, so that's it for name as suffix. Now let's go to name as prefix. Name as prefix. If you recall what we've discussed earlier on, name as prefix is got from substituents. What are substituents? As I said earlier on, the atom or group of atoms that will take natural place of hydrogen in organic compound. Just like we have substitution in math. So let's see name as prefix. So we'll take some examples. Substituents, name as prefix. All right. For a substituent like CH3, which is an alkyl group, the name as prefix is methyl. Okay. For a substituent like CH to CH3, or it can be CH3 here, CH2 there, depending on where it appears. But let me leave it as this. The name as prefix is ethyl. Then we have other atoms like the halogens, like chlorine is chloro. Fluorine is fluoro. Bromine is bromo. Iodine is iodo. And so on and so forth. We have others, but I will just leave it at this. Okay, so these are items or group of atoms that would take the natural place of hydrogen in organic compounds, and they are referred to as well substituents. So their name are shown beside them. All right, so having discussed name as roots, suffix, and prefix, it's high time we go over to taking the examples that follow. Now, before we begin to take the examples, okay, there are some underlying rules that I may not state, but as we move on with the examples, the rules will be coming on board, okay? Because if I state them, you may not understand what they are saying until you will see them in application, okay? So let's take examples. So number one, I'll start with something very simple. I have 1, 2, 3, 4. Okay, I have this, I have this, 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 this. Okay. I'll also give you the condensed or compressed version of this structure. So it is either this, or I can come here to say or CH3, then CH2. I'm here now. CH, then CH3. Oh, this place will not accommodate it. Let me bring it down. Bring it down here. So I start again. CH3. This is a condensed structure. Then here I have CH2. I'm here now. CH. Then here CH3. I can put it in bracket if I want. Then over here now CH2. Then the CH3. All right. So as a learner, when they give you an exercise and it is in this condensed form, my advice, expand it fully like this so that you would name it without making mistakes. All right, so first and foremost, let's try the number one thing to do in the sequence is to name our root. So let's go. We have different possibilities. The first one is 1, 2, 3, 4. That's the first possibility. Another possibility is 1, 2, 3, 4, 5. Okay, another possibility is 1, 2, 3, 4. So in all of the possibilities, this is the one that will work. This possibility here, this way, this is what is will work for us. Why? Because it has the highest number of carbon atoms, which is 5. Other possibilities we saw only gave us 4. Okay, even if we go straight up 1, 2, 3, this is 3, which is still less. Okay, so since the root, the longest continuous chain we've chosen, contains 5 carbon atoms, then the name as root, if we go back to what we discussed now, the name as root will be pents. pent because the longest continuous chain has 5 carbon atoms. 5 is for pent. Now let's see. We can also identify the longest continuous chain here as well. This is 1, 2, 3. This in bracket is not part, it's a branch. 4 and 5. As a teacher, I can name it from here, but for you, a learner, please do this. Okay. Do we have, okay, the next thing is to name the suffix. Do we have any unique thing apart from the bond? No. So the functional group is single covalent bond, and it is one and only functional group. So for that reason, the name and suffix is what? A-N-E. Ain. All right. And do we have any substituent? None. Nothing has taken the place of hydrogen. It's only hydrogen atom. So because of this, the name of this compound. Oh, do we have any substituent? Please, yes. We have a substituent here because it's not part of the chain. So it is a substituent. And in naming this substituent, please listen. In naming this substituent, the rule says that we must assign the lowest numbering order possible to it. Okay, what does that mean? I've counted from here 1, 2, 3, 4, 5, and this CH3 here, which is still what is here, is attached to carbon atom 3. So let me count from downwards. So this is what I did here: 1, 2, 3, 4, 5. Okay, so I can start from this way again. Let me count: 1, 2, 3. Although either way, it is still attached to carbon atom 3 either way. So since it is attached to carbon atom 3, either I count from left to right, or left this way down, or up that way, it still remains the same thing. So for that reason, any numbering order goes. So, and the substituent, this is the substituent here. This substituent here. And the name of this substituent, CH3, is what? Methyl. So since it's methyl, it is methyl attached to carbon atom 3. So for this reason, even here, it's also attached to carbon atom 3. So the name as prefix will be 3-methyl pentane. So the IUPAC name of the compound you're seeing here is 3-methyl pentane. Why? CH3 is attached to carbon atom 3. That is 1, 2. Why is it pent? Because the longest continuous chain has 5 carbon atoms. Then, why do we have ANE, AN, as the suffix? Because the functional group in this compound is only single covalent bond. I hope this appeals to your senses and it makes sense to you. Okay, that's it for this number 1. So we'll take another example. Take another example. We'll take another one. Number 2. Let's say we have something like this. Okay, so we have H3, H3, H here, there, here, here. If you notice around the double bond, the number of hydrogen atoms will be less. Why? Because of the double bond here, it's unsaturated. Of course, around every carbon atom, it should only contain 4 bonds. So this is 2, 3, 4. All right. So here we have this, have this, have this. We have hydrogen, hydrogen. I have chlorine. I have bromine here. I have chlorine. I have bromine again. I have hydrogen. I think that's all. I can see give us the compressed version of this. Okay, let me give us the compressed version. Sorry for that. The compressed version of this would be CH3. I'm starting from here. CH2. Okay, CH. Then I'm here now. CH3. This, it's an attachment. Then CH2 here. Then BRCL. The same thing here. BRCL. So this is a compressed version of the structure up here. An expert can name it from here, but a learner, please do expand it. And when it's compressed, if you check around here, you see that the number of hydrogen atoms is not up to 2. So that will tell you that indeed this is no longer an alkane, but another compound that is unsaturated. You be careful while working with this. Okay, so first things first, based on our sequence, we are meant to name the root first. So the root here will be, let's check. Here we have 1, 2, 3, 4, 5, 6. That is the first possibility. Another possibility is 1, 2, 3, 4, 5, less than 6. Another possibility is 1, 2, 3, 4, 5, 6, 7, 8. Of course, 8 is the most. So our longest continuous chain would be this, the one that has the highest number of carbon atoms. This would be our longest continuous chain, where I'm doing the broken line. That's our longest continuous chain. Okay, this is our longest continuous chain, and based on what we said, it has how many carbon atoms? 1, 2, 3, 4, 5, 6, 7, 8. So this is the name as root, since it has 8 carbon atoms, will be what? Oct. Okay, it will be oct. All right, so the next thing is to name the suffix, and there are some underlying rules here. Let me mention the rules before I apply them. The rule says that whenever you have a functional group, that is a suffix, okay, and a substituent, that is a prefix, that you must assign the lowest numbering order possible in favor of the suffix, which is determined by the functional group, as against that of what? The substituent. In clear terms, the suffix must have the lowest numbering order, and if you choose that lowest numbering order, you must stick to it even in naming the substituent. Even if it doesn't favor the substituent, it doesn't matter, provided it favors the suffix, you stick to it. Okay, so on based on that, let's see. If we start from this end, we have 1, 2, 3 for the double bond, which is the major suffix, major functional group. If we start from here, we'll have 1, 2, 3, 4, 5. Of course, 3 is lower than 5, so we will stick to this numbering order here. 1, 2, 3, 4, 5, 6, 7, 8. So this numbering order we must use in naming every other thing as far as this compound is concerned. So I will still do it here. 1, 2, 3, 4, 5, 6, 7. Okay, let me see. 1, 2, 3, 4, 5, 6, 7, and 8. Yes, that's it. Remember, in the compressed form, I'm only looking at where the carbons are. The carbons are made up the longest continuous chain. All right, so let's go to the name as root. So the name as root will be this double bond is on carbon atom 3, so it will be 3 in, E-N-E. Why in? Because it is double covalent bond. Why 3? 3 here tells us that it is the double bond is on carbon atom 3. Okay, so that is sorted. Now let's go over to the name as prefix or prefixes. So in trying to identify our prefixes, we must look out for, okay, what are the items in this compound that are not hydrogen? So let's go. This is one of them. This is 1. This is 2. This is 3. This is 4. And this is 5. There are 5 substituents. All of these things are circled with broken lines. They are all substituents, things that have taken the natural place of hydrogen. Okay, and in naming substituents, mind you, they must be named in alphabetical order. That is another rule. And again, in addition to naming them in alphabetical order, if you have more than one substituent, identical substituents, we have to use the Greek prefix di for 2, tri for 3, and so on and so forth, stating the numbering order they have on the chain that we have chosen. All right, so in alphabetical order, okay, this is bromo. Okay, this is another bromo. This is chloro. This is another chloro. These two are chloro. Then this is methyl. Okay, so these are the substituents present here. 2 bromo, 2 chloro. Okay, 2 of them. and 1 methyl. So in alphabetical order, bromo will come first, and bromo is on carbon atoms 7 and 8. So it will be 7, 8. When we have two numbers, we separate them with comma. Then after the number, we'll put a hyphen. Then because it's bromine and there are two of them, it will be dibromo. Okay. Then we are done with bromine. The next in alphabetical order is chlorine. So chlorine is still on the same 7 and 8. So hyphen 7, 8 hyphen dichloro. Okay, I'll be rubbing this up because it won't accommodate it. I'll rewrite it again. Then the next substituent is methyl, and methyl is on carbon atom what? 5, as we can see. So this is hyphen 5 methyl ox 3 in. I hope we understand this. I'll leave this a bit for you to see and know why it happened like this. So from the compressed structure again, you see that the methyl is on carbon atom 5. The chlorine and bromo, we have bromine on 7 and bromine on 8. We also have chlorine on 7 and chlorine on 8. That's why you see 7, 8, 7, 8. Okay, the die shows that there are two of them. Okay, then 5, that is where we have the methyl. Then oct is because we have 8 carbon atoms in the longest continuous chain, and 3 is because the double bond is on carbon atom 3. Then in is because it's what? Double covalent bond. I will say thank you for viewing, but we'll continue this in the next part of the video. Okay, we'll continue this in the next part.